Hi guys, in this episode of Shri series, we're going to be talking about simultaneous equations, bit more specific, using substitution to solve the equation. Alright, so I've got two questions for us to go through, and we're going to be using substitution to solve these simultaneous equations. So I've got one question here, and in the other tab, I've got another question as well. Now, using the basic processes of algebra, there are two methods of solving simultaneous equations. One is substitution, and you've got elimination, all right? And of course, you've got the other methods using line graphs as well as using matrices. But for the time being, we're going to use substitution, all right? So there are two things I'm just going to explain briefly. What are simultaneous equations and what is substitution, all right? So what are simultaneous equations? So these are equations, or these are pairs of equations where you need to solve unknown values of the letters x or y in this question, or a or b, or x or z, and you're solving it at the same time, and hence it's simultaneous, all right? Now, if you've been looking at my previous videos, we've done some basic process of algebra, to be more specific, substituting one number with another one. So I'm just going to give you a simple recap and a simple question here. Suppose you've got y is equal to a plus b, and let's say a is equal to 3 and b is equal to 4, and we want to work out what the final answer is. All you're simply doing is, in place of a, you're putting 3, and in place of b, you are going to put 4. So that now becomes 3 plus 4, and the answer is 7. So that is a simple substitution. All right. However, when you're solving simultaneous equations, as you can see in this question, you're not getting numbers or letters to substitute. You're actually substituting expressions, algebraic expressions. All right. So what I'll do is, after I erase this, we'll go to the question here, and I'm going to read this out. So these are the two pairs of equations. You've got 2x minus 3y equals negative 8, and y is equal to x plus 3. And so we need to use substitution to solve this simultaneous equation. All right. So what I would do is, when I've got these equations here, I would label that as equation 1, and I'll put that as equation 2, all right? And the reason why I'm doing this is just to simplify what I'm going to be doing for easy understanding, all right? So what am I going to be able to substitute, all right? Now, the beauty about equation 2 is it already tells me what y is, and y is equal to x plus 3. So therefore, what I need to do is, in place of y, in the second equation here, negative 3y, I'm going to put x plus 3 in place of y in the first equation. So I'm going to use the second equation, which is y is equal to x plus 3, and substitute it in the first equation where there's a y. All right. So let's see how we go about that. So we're going to do 2x minus 3. I'm just going to use a different color so you can see there, equals negative 8. So what I've now done is, in place of y in the first equation, I've now replaced y with x plus 3 from the second equation. All right. Now, if you've looked at my previous videos, we've had linear equations of this format, all right, where we need to expand. Okay, so what do we do in expansion? We get rid of the brackets. We multiply the numbers or the letter with the respective components in your brackets. All right, so what I'm going to do is, I'm going to draw an arrow just to explain to you what I'm going to be doing. So I'm going to be multiplying negative 3 times x and negative 3 plus 3. All right, so what do we get from there? So now we're going to expand this. 2x minus 3x minus 9 equals negative 8. All right. So we're now going to group the x's together. Now 2x minus 3x is negative x minus 9 equals negative 8. All right. So what I'm going to do is, I'm just going to continue from there. So we've got negative x minus 9 equals negative 8. All right, negative x minus 9 equals negative 8. So what do we do from there? there's two methods we could do. Either we could put negative x over the equal sign, so it becomes positive x, or we put negative 8, or we could leave negative 8 here and move that over there. I like to work out the value of x and not negative x, all right? So what I would do is, I'm just going to show my arrow here. I'm going to move negative x there, and I'm going to move negative 8 there. So the sign's going to well and truly change, all right? So now that's going to be 8 minus 9 equals x, and therefore x is equal to negative 1, all right? So we've got x is equal to negative 1. Are we done? No, we've got the value of x. We now need to find the value of y. All right. Now this step is now easy because we've worked out what x is. We just have to put the value of x in either equation 1 or equation 2. Now here's the tip. You put it in an equation that is easy to work out. All right. So between equation 1 and equation 2, I'm more happy putting the value of x in this equation because it's more easy to solve. Of course, you can put the value of x as negative 1 in your first one, but it might take longer to solve. So you want to make your life easy. All right. So what I'm going to do is I'm going to put the value of x as negative 1 in my second equation. And what's that going to be? So I'm going to write down the equation that I'm going to put it in. And so y is equal to negative 1 plus 3. And therefore y is equal to negative 1 plus 3, which is 2. All right, so therefore we've now worked out the value of x as negative 1 and the value of y as 2 in this equation. We've used substitution to work this out. All right, I'm going to go through another question and then we're going to consolidate our understanding. All right, so let's look at the next question here. So we've got another pair of equations. So we've got y is equal to negative 3x plus 2. All right, I'm going to put that as equation 1, and y is equal to 7x minus 8, and I'm going to put that as equation 2. All right, now this one here seems pretty straightforward because literally what you're doing is you've got two values of y's given to you. So technically, you just have to equate. So what I'm going to do is I'm going to put the y, which is negative 7x minus 8, into that equation. All right, because it's literally substituting. So what is my equation going to be now? All right, so you're going to get 7x minus 8 equals negative 3x plus 2. Because that's a y, and that y is equal to negative 3x plus 2. What do we do from there? We're going to be grouping like terms and unlike terms. So I'm going to use the arrow. I'm going to put the x's on my left-hand side, and I'm going to put the numbers on the right-hand side. So technically, that negative 3x will now be plus 3x, and that negative 8 is going to be plus 8, because you know very well when you move numbers over the equal sign, the sign will change. All right, so what are we going to get there? We're going to get 7x plus 3x is equal to 2 plus 8. And that's going to be, I'm just going to move here. So we've got a bit of space. And I'm just going to put an asterisk there just to show I'm going to continue. So 7x plus 3x equals 2 plus 8. Now we know very well 7x plus 3x, basic algebra. And 2 plus 8 is equal to 10. And then we divide it by 10. Divided by 10. Therefore, x is equal to 1. All right. Are we done? No, we're not yet done. We need to find the value of y. All right. So what do we do here? We're going to put the value of x either in the first one or in the second one. All right. So let's put it in the second one. So I'm just going to put a double tick just to show you what I'm going to substitute it in. So that's going to be y is equal to 7x minus 8. So y is equal to 7 minus 8, and therefore y is equal to negative 1. And that's my answer. So we've got the value of x as 1, and we've got the value of y as negative 1. All right. Now, is it possible to get fractions? Is it possible to get decimals? Yes, you can in simultaneous equations. In the two examples I'd shown you, we had whole numbers. Negative numbers as well as positive numbers. All right, so let's consolidate. What do we need to do when we've got two equations? So let's go back and then we recap what we did in the first one. So if you look at the first one here, we needed to substitute the value of y and put it in the equation. All right, and then we had to expand. You will notice that the first thing you need to do is substitute, and from there onwards, it's just the basic processes of solving linear equations. And that's the beauty about simultaneous equations. All right, you just need to do one step, which is substituting, and then you work your way through all these steps. All right, I'm just going to tick them. This step, that step, this step, and that step. All these steps are basic processes of solving linear equations. All right, you need to understand your expansion. If you don't know how to expand, the question is going to be hard. You need to know your substitution. All right, as you can see, if you don't know how to substitute the value, this question is going to be hard. You need to know how to group like and unlike terms to solve a linear equation, because if you don't, this question's going to be hard as well. All right, going back to the second question here. As you can see, we were substituting. That first substitution, straightforward. And then from there onwards, from this step to that step to this step and that step, it is all basic linear equations. All right. So if you're not sure about how to work on linear equations, please look through my YouTube subscribe channel, Sri Series, which talks about linear equations. All right. In the next set of videos, we're going to be solving simultaneous equations using the process of elimination. All right. Thanks guys for listening. Bye now.